Hello, everybody. My name is Mr. Gopal, and today I will be your physics teacher. We're going to take a journey into energy, specifically the conservation of energy, which means that it's conserved, but it's not always present in the same form. So we want to know specifically what happens to potential energy as an object moves, all right? And before we jump into the activity that I'm going to use in order to illustrate this, I'll just take note that what the lesson does is we consider roller coasters, right? We consider roller coasters as situations where we build potential energy and we spend it in different ways. And I'm going to consider this part of the roller coaster where I'm waving my mouse. This part is usually the part at the beginning where you kind of crank up. I know I'm filled with fear, but you crank up a very, very steep and long hill and you get to the top well above ground. And then you kind of go into a twisty downward motion where that energy gets converted. And we're going to consider the type of energy that it gets converted to and situations where it's completely conserved versus situations where it isn't. And in order to do all of this, we're going to take a look at something called the Energy Skate Park. I love PHet simulations. The University of Colorado at Boulder has created all these wonderful animations that are interactive, which means we can change things. And this one in particular is with a skateboarder on a half pipe. So if I hit play, or before I hit play, I'm going to take note of the following. I've got a pie chart following this skater. I also have a bar graph that's easier to see, and I have energies labeled blue for potential, red for thermal, and green for kinetic. I'm just going to point out what we already know, which is that potential energy is the potential to do something. It's almost like stored away so that it can be used for other things. And the reason why right now the skater only has potential energy is because the skater is still, and they're at the top of the hill. What you're going to realize from class and conservation of energy, and from me as well, is that potential energy exists whenever we are at some distance above the ground of the situation. Okay, so this skater in particular is at a far distance at the top of the half pipe above ground, and that's why the skater has that bar of potential energy. If we hit play, let's see what happens. So we see it's all being converted into what we call kinetic energy. You might have heard the word kinetic before, and it's used to refer to motion. Okay, so if someone's behaving kinetically, that means they're moving all over the place. I'm behaving kinetically right now as I'm waving my arms, thinking about things, all right? And we can see that it gets converted completely to kinetic energy when we hit the bottom of the half pipe, all right? There, the skater is completely has kinetic energy, and as you get to the top of either end of the half pipe, all that kinetic energy gets converted back into potential energy. And so it's also fair to say that the motion of the skater is fastest when at the bottom of the half pipe and when the skater has completely kinetic energy, and also at the moment when that blue pie becomes completely blue, and when it eats away all the green, there is just a split second, just a moment in time when the skater completely stops motion, and that's when he or she has all potential energy. All right, so at the bottom, it's converted all into kinetic as the movement gets faster and faster. All right, and then it's converted back up into potential as we scale back up to a higher height. Notice also that the thermal energy is non-existent in this situation. So this is the intro skate park, and in order for us to take a look at friction and its effect on the situation, we have to head over there to the second one. So right now, I've got my skater at the bottom. For some reason, it's all thermal. I'm going to restart this situation. And let's take a look at what happens. All right. Notice that the skate park in this case is called friction. I'll play this again. We'll analyze the differences. But the important thing to note is that the skater is not endlessly going from side to side. This situation that we're looking at is far more realistic. And the reason why it's so much more realistic is because there is friction between the wheels on the board and the material of the half pipe. All right. If you think about it, you might think of tires squealing, rubbing your hands together, dragging something across the table. I'm dragging my cell phone across my desk right now. All these situations involve a drag force, and that force is called friction. You will encounter it in more detail in the units to come as we make what we call free body diagrams. But the idea here is that friction is dragging against the movement of an object. So if the skater is floating that way, friction is pushing back the whole time in the opposite direction. And when we rub our hands together and create tremendous amounts of friction, hopefully you can feel that your hands warm up. And so thermal energy is released. And that's what makes this skate park more realistic than the intro skate park. Now I'm going to restart the skater and play this, and let's see what happens. So we start at the top, and with each roll across the half pipe, particularly when we convert to kinetic, that kinetic in turn gets converted to thermal. So this is a very common process. There's almost a chain of conversions happening when we talk about conservation of energy, right? In what we would call a closed system. This closed system consists of the skater on the skateboard and the half pipe, all right? So nothing else from outside is coming in. And that's what I mean by a closed system. And in closed systems, we have conservation of energy. Now, again, like I said earlier on, that energy changes form, but the total amount of energy, as you can see, represented by the gold bar all the way to the right on the bar graph, remains the same. It's just what type of energy is being utilized or being expressed, you could say, changes. So again, potential energy, that is our energy that we store up, particularly when we go to higher places above ground. The kinetic energy is released by movement downwards, in this case, or it could be movement along some other kind of slope down. And then finally, thermal energy is created in this situation in particular by the friction between the wheels of the skateboard and the material of the half pipe. We will come to more complicated scenarios with conversion of energy, but for now, we know three types: potential, kinetic, and thermal, and we can see them all interacting in this particular skate park. Thank you very much, and I hope to be with you again soon.